Alright students, welcome back to week 4, chapter 6, database processing. So last chapter we talked a little bit about cloud computing and cloud storage. We're going to go a little bit more in depth into it in chapter 6. So really, what is the cloud? I think this sentence sums it up perfectly. It's the elastic leasing of pooled computer resources over the internet. But what do we mean by elastic? The cloud allows you to automatically adjust for unpredictable demand. You might have spikes in customer traffic to your website. The cloud will help you adapt to that without maintaining bulks and bulks of servers. Because it's pooled, because we're using the same hardware, we have economies of scale, and this is a savings that we'll be able to pass on to the consumer. So what led up to the cloud? If we look at the mainframe computer era in the 60s, 70s, and early into the 80s, we had large-scale, room-sized computers. These mainframes did all of your processing and data storage in that computer. We had thin clients or terminals. Sometimes you'll hear these referred to as dumb terminals because they were nothing more than a monitor and a keyboard. These connected directly to the mainframe and served as your inputs and outputs. No processing or storage was done on the thin client. As we move into the late 80s, early 90s, we start to develop the client-server era, where the clients, your computers, also started to have applications, data processing, and storage just like your servers, but we had the internet in between. So this image here shows your mainframe era. Your thin client or your terminal is connected directly to the mainframe and only to the mainframe it operates with. Your mainframe stores all of your application, your data, and your processing. And typically, the mainframes were there for a specific reason. If you were doing banking, you would have one bank mainframe. You couldn't bounce back and forth between applications, at least on some of the early mainframes. Your client-server era, we see that the standalone client and the server both have applications, storage, and processing, but because they're connected to the internet, your client can connect to multiple servers, sometimes multiple servers at once, doing various applications. Think of it if you were checking your mail, you were streaming music, and you were reading a blog. 3 separate servers accessing 3 different applications with 3 different data storage. In the early 2000s, mostly 2008, we started to see internet become fast enough and reliable enough that we can run applications remotely. So this is the Google Docs that we talk about. Google Docs is totally a cloud service. And once we get more into 2010, 2015, we're seeing a lot more IoT, Internet of Things devices that rely solely on the cloud. You know, your smart light bulb, your smart speaker is useless without its connection to the cloud because these devices themselves don't have applications on, don't have data storage, they don't have processing power to do anything. There are micro servers in there that can manage some things, but the vast majority of it is stored onto the cloud. Our reliance on the cloud touches all of our devices. Your phone's connected to the cloud, your iPads, we're seeing thin clients again, and of course your laptops and desktops rely heavily on cloud computing for the vast majority of the applications that you use. So why do organizations prefer the cloud? Well, it's low cost. Like we talked about in chapter 1 and 2, the cost of data storage and data processing on cloud servers is fastly approaching zero. And elasticity, like we talked about in the first slide of this PowerPoint. And there's a slide about 2 or 3 slides down that gives a really good example of elasticity. When does the cloud not make sense? There are some sectors that you legally cannot use cloud storage. Government contracting, for example, sometimes pharmaceuticals you're not allowed, and sometimes in some really cutting-edge technology firms where they do a lot of R&D. We need to have physical control over that data. It needs to be housed in our building that we can lock up and remove and transport if we need to. Recently, we've seen Amazon Web Service come out with AWS Gov Cloud. It's a service tailored specifically for the government and government contractors that meets a lot of the wickets of having quote-unquote, locked up servers. we're still seeing this rolled out. I know my company, we've looked into it. It is fairly costly, but it's cheaper than maintaining servers on site. So AWS GovCloud is definitely something to keep your eye on in the near future. So how do organizations use the cloud? So this is the example I was talking about before. And, it doesn't have to be the Academy Awards like here. This could be a Super Bowl, any large televised event. We have a company that wants to run an ad during this event. We know that realistically, hundreds of thousands up into the millions are going to watch this commercial. Now, how many of those people are going to go to our website? We really don't know ahead of time. If we maintained our website in-house, if we had all the servers and all the processing power for our own website, we would have to take a guess. How many visitors do we expect to see that night? Because what we don't want to happen is this website to crash. And sometimes you've seen this happen in the mid-90s during the Super Bowl. You'd see a Super Bowl commercial, everybody would go on their computer, and you would overload the website, and the websites would crash. That's an embarrassment to the company, and you can lose consumers. But if we have this website on the cloud, if we have an agreement with GoDaddy or other large industrial website providers, they have the elasticity to up the bandwidth, up the processing power as needed to meet the instant demand for your website. In the long run, this reduces your cost substantially because you're paying a flat rate for the service you're getting from your provider. But as you see those peaks in demand, you're just charged for those peaks. This next slide goes over some of the comparisons of cloud service offerings. On the far left, this is everything in-house. This is your network storage, your OS and your applications, everything we're doing internally. So we have full control over this. If we're expanding, if we know we're going to get more customers to our website, we need to beef up our network. We need to beef up our storage. On the far right, SaaS, software as a service. Whoever your provider is, they control everything. You just give them requirements, they make applications happen, they control the data. You're just a user at this point. You're paying for the convenience and you're paying for the elasticity. Infrastructure as a service and platform as a service is more of a give and take. Maybe you want to manage your applications and data, or maybe you really care about what operating system and middleware you use. So there's a lot of compromises depending on what type of cloud service fits your needs, but there are many layers to this, and most of the vendors will really sit down with you and go over a lot of your options. The last thing we're going to talk about is how does the internet work? And this is an extremely broad topic, and we can talk for days or weeks on this, but this is going to be a pretty quick 30,000 foot overview of some terms that you may be unfamiliar with. And there are more, but I think the ones we're going to talk about might be new for you. If not, it's going to be a good refresher. I always find anytime we're talking about a complex or a new idea, it's good to relate it to something that we know. Everybody is sent a letter or mailed a package. So, as we're going through the postal system, we need a package or a letter. You put their name on it. You need an address. We get that address from a phone book or a directory. We want to track it so it goes through registered mail and it goes off on an airplane or a truck off to its destination. The internet works very similar, but instead of a package, we use a packet. Instead of a name, we use a domain name, bigbank.com, google.com. We get that through a DNS. We have an address, that's the IP address. There's public and private IP addresses. TCP allows us to track it, and it goes through your carriers, whether it's your Comcast, Verizon, or Sprint. IP addresses may be new to you. These are Internet Protocol addresses. Every device we have, well, the vast majority of devices we have right now rely on IPv4, Internet Protocol version 4. You may have seen this if you've done anything with your home router. The address that you put into your address bar to access your home router is probably something similar to 192.168.1.1 or maybe .1.0. This is the physical address to get to your router. It's in dotted decimal notation, and it only gives us about 4 billion addresses. That's quite frankly not enough for as many devices that we have and are currently connecting to the internet. Think of all the Internet of Things devices we see now: smart speakers, smart light bulbs, smart refrigerators. All these things have an IP address. They need to go on the internet, and the IP addresses have to be unique to that device. Otherwise, we're going to get routing conflicts. This is where IPv6 comes in, Internet Protocol version 6. It's a hexadecimal notation with a vast amount of more addresses to allow many, many more smart devices to connect to the internet and have a unique address. Domain name system, or DNS. This is the unique name affiliated with a public IP address. So these are your website addresses. And it goes through URL, Uniform Resource Locator, and these could be HTTP or FTP. HTTP, Hypertext Transfer Protocol, is used to access primarily websites on the internet. It's usually a one-way. Your computer goes out to the website and requests the information, and the website just reads it off to you. While on the other hand, File Transfer Protocol, FTP, is used to transfer files from one host to another. You might see this on some older message boards. You might see this if you go to some website where you can upload and download data. And it would be, that's what you would type into the Explorer bar. It would be FTP : the address, vice HTTP. Talked a little bit about private and public IP addresses. Your public IP address, identifies a unique device on the internet. This is your website address. They all go through ICANN, the Internet Corporation for Assigned Names and Numbers. And this is the organization that ensures that there is only one Google.com, that there is only one Ford.com. And they also control .orgs, .nets, .us, and anything else. This just gives the oversight needed to ensure we don't have conflicts. And your private IP addresses, these are the devices that you'll find on a private network or your local area network, something you might find in your house. The last thing we're going to talk about, and I really encourage this to be a jumping off point to do some research on your own, is net neutrality. We've seen this come up a lot in the news recently, and I think we're going to see it pop up a couple more times. The principle behind it is that all data on the internet should be treated equally. There's pros and cons with this, but the main 30,000 foot view is carriers shouldn't be allowed to decide which websites load quickly. They shouldn't have control over which applications are allowed on their network, and they shouldn't decide which content is acceptable. Think about it. If you had a provider that had a deal with Netflix, maybe you signed up for their internet service and you get Netflix included with that. Without net neutrality, they could start to slow speeds to Hulu or Disney Plus because they want to prioritize the speed to Netflix, their partner. Think if Sprint didn't allow Instagram on their network. So now only Verizon people or anybody not using Sprint would be able to access Instagram. If you had a Sprint device, you'd have to find a Wi-Fi hotspot that wasn't controlled by Sprint to access Instagram. The third point, deciding which content is acceptable. This is where a lot of people get hung up because there certainly is a lot of undesirable content on the internet, sometimes illegal content of the internet. Should we be able to hinder access to that if it is illegal in your country? And that's the other thing. If you had a VPN, does that prevent accessing illegal information in your country? So this is a hot topic. We've seen it before. We're going to see it come up again. So I really encourage you to do a little more research on net neutrality just to personally educate yourself. So that pretty much sums up what I wanted to talk about with Chapter 6. Please keep working on the homework. If you have any questions, reach out to me and let me know. Thank you.